begins. So we'll get started. So first of all, I wanted to thank you for signing in to come to the 2022 Home on the Range webinar series. And I'd like to thank the sponsor of the Kamloops Large Animal Veterinary Clinic. I'm Eleanor Bassett. I'm the Rangeland Research Ecologist with Range Branch, and I'll be your host for today. And just a quick reminder that if you're not used to Zoom, please put yourself on mute for the time being. I'll introduce Amanda, our presenter for today. She'll have 15 or 20 minutes to present, and then we'll have questions at the end. In the meantime, you can always put your questions in the chat and we'll get to them at the end, or you can also use the little raise your hand icon and unmute yourself for questions during that discussion time. And just a little plug as well, next week, November 1st, there will be a presentation, same time, Rangeland Resilience for Rangelands, and that's by Bob Gillespie. So, Amanda Miller, oops, let me just get this out of here. There we go. Amanda Miller is passionate about rangeland stewardship and conservation, with a keen interest in providing ecological tools and strategies for the long-term sustainable land management. Applied science extension and effective communication with stakeholders and land managers are her key areas of interest. She's got a master's in rangeland and wildlife resources from the University of Alberta and has been working as a professional agrologist since 2016. Amanda worked as a rangeland specialist for the government of Alberta from 2013 to 2019, where she worked to develop ecological tools, conduct applied research, and policy solutions to address emerging rangeland issues. She's the owner and founder of Palouse Rangeland Consulting and works largely with BC Cattlemen's Association. She is a supporter of sustainable beef and cattle as a conservation tool. So Amanda, if you'd like to go ahead and share your presentation, I'll stop sharing.
Okay. All right. Well, thank you so much for the lovely introduction, Eleanor. I really appreciate it. And so today I'd like to talk to everyone about wildfire risk reduction through targeted grazing. Here we go. So this has been a long-term project. It's been ongoing for we've been doing research on this project since 2020. So we have 3 years of field research. Where this came from was in the 2017-2018 fire seasons, which were very, very severe fire seasons here in British Columbia, and I think in large parts of the West. One of the things that we found during those fire seasons was that there was value in some of the agricultural practices across the landscape, specifically grazing, in helping to change fire behavior by slowing, turning, or stopping fires. And these were kind of considered agricultural fire breaks. And so because the scope and scale of the devastation from these fire seasons was quite large. In 2017, we saw 1.2 million hectares burned, 65,000 people were evacuated, and there was almost $650 million in fire suppression costs. 2018, similar story, 1.3 million hectares burned, 2,200 people evacuated, and 615 million in fire suppression costs. Then, the story continues. 2021, almost 1 million acres, $565 million in fire suppression costs. In 2022, we don't know quite yet, but we saw about 100,000 acres burned, or sorry, hectares burned. So it really has highlighted the importance of looking into these types of different strategies to address some of the fire risks that are seemingly increasing across the province. So to do this, BC Cattlemen's Association partnered with the province and ranchers to help develop this pilot program that looked at investigating wildfire risk reduction through targeted grazing. And this would be through using targeted grazing of cattle to reduce or break up fine fuel loads and subsequent wildfire risk next to communities, utilities, and transportation corridors. So the question is, that a lot of us would have is, what is targeted grazing? It's kind of a novel term. We don't hear it all the time. The definition of targeted grazing is that it is the use of a specified kind of livestock at a determined season, duration, and intensity to accomplish defined vegetation and landscape goals. So basically, we're putting animals in a certain area to do a certain thing for a certain amount of time. Most fuel management projects have historically been focused on making changes to tree canopy characteristics. So that's things like thinning, the removal of trees, decreasing the overall number of trees per hectare, perhaps changing species from conifer to deciduous in an effort to reduce wildfire risk, and or pruning or removing the understory to address ladder fuels. So one of the things that often comes out of the most largely used fuel management work, which is thinning, is that you get an increase of herbaceous material over time because you've opened up that overstory, you have more light resources, you get a flush of grasses generally that grow following those treatments, which unfortunately turns into one of our most volatile and easily ignited fuel types, kind of create a little bit of tinder out there. So the goal of this project was to use targeted grazing to address that fine fuel load. So the overall goal, reduce our fine fuel loads or to end or break up the fuel continuity while ensuring that our other values that are really important on these landscapes are not negatively impacted. So in most cases, well, largely that means that we're ensuring that we're falling within our required stubble height and forage use levels across public land. So how did we do this? Well, we established 4 sites in 2020, 1 in Peachland, Summerland, 2 in Cranbrook, and then a 5th site was actually added in 2022 in Southeast Kelowna. So monitoring occurs within this area of interest in these sites, which is within 2 kilometers of community infrastructure, and our intensive data collection is concentrated within 400 meters of the infrastructure. And this is the area where we have a lot of concerns with things like spotting, ember spotting across. So 400 meters based off of information from BC Wildfire Service was the most important area to be targeting in these treatments. And this monitoring is composed of two main different types of levels of monitoring. One is intensive monitoring, which occurs once at the season in these established permanent macroplots. And then 2 is extensive monitoring, which occurs historically every 2 weeks during grazing, although we found in 2022 with our long-term partners that there were no management issues. So we just did extensive monitoring after the grazing treatment. So extensive monitoring provides this larger scale review in our 2 kilometer boundary of the study site, 2 kilometers within community infrastructure. And it provides that very broad coverage and allows us to look at certain indicators. We look at the leading plant species height and estimated cover. We look at estimated grazing use, fuel continuity characterizations. We do riparian health assessments because those are key areas of concern. And then we also take a look at plot attributes such as slope aspect and other important notes. Often we need to monitor invasive species as well. And that's been important for ensuring that the grazing treatments don't lead to the increases in invasive species and other potentially negative outcomes. So the intensive design is provides us with quantitative data, and it occurs in these small randomly selected macroplot areas within 400 meters to community infrastructure, and provides us with data that we can use for statistical inferences. And it occurs after grazing has been completed for the season. And so we look at a lot of different variables for this because this is we want to look not just to ensure that we're meeting targets for use to reduce fire risk, but we also want to ensure that we're not having negative impacts on things such as ecological integrity. So that includes collecting a whole slew of data across these different variables, which are plant biomass, litter biomass, identification, the different woody fuel types, the fuel continuity, conifer regeneration, which can be an issue in areas where you've had overstory thinning, and then different range health indicators such as soil movement, plant recruitment, soil crust, etc. And so that occurs within that 400 meter zone. You can see this is our Cranbrook East site. And we've got our 3 little macro plots in orange there. So this is a schematic of what each of those macro plots looks like. We've got our 5 forage cages, which we also have an uncaged pair with, a baseline transect where we look at stubble height and fuel continuity, our plant community transects, and we do range health assessments across this broad area as well. So there's an awful lot of data that's collected out of this to provide us with the best information possible. So for our Cranbrook East site, which is the one that I'll speak to the results of for this, because it's the one that's had the longest targeted grazing, longest term application of targeted grazing out of all the sites, and has had some excellent stewardship by our 10-year holder partner, the Tebow Ranch. So it is found in the Pinegrass Twin Flower biogeoclimatic site series. And it is a plant community composed of Douglas fir, western larch overstory with a lot of Oregon grape in the understory, along with pine grass and western fescue. So the study site, this is a picture of it. It was in good health overall. The plant communities are dominated by these very vigorous species, indicative of forested and some pockets of seeded agronomic communities. The overall average grazing use that we found from our extensive plots, including our macro plots too, was 29% across the study area. So we're removing about 1/3 of the forage that in a very even use across the whole study area. Biomass, which I think is one of our key indicators, what we saw. So we've got these different categories of biomass up on the screen there, and the ones that have a little asterisk have a significant difference between the grazed and ungrazed. Ungrazed is in gray and grazed is in green. So our total living biomass on the far right of that graph was significantly reduced between caged non-grazed controls and our grazed samples by 27% or 165 kilograms per hectare, which was pretty cool to see. It also made me realize, like, hey, I can actually, accurately identify percent utilization, because 29% is very close to 27%. So this represents a moderate amount of fuel reduction, from 616 to 451 kilograms per hectare, again, about 1/3 reduction. And pine grass was the main forage species across the area. It was significantly reduced by 25% from the grazing treatment. Then we also had some other grasses out there that included things like Ross's sedge, western fescue, and northwestern sedge, and they were actually reduced by 81%. Which is quite a lot. However, it's just such a very minor component. Like, it was only at 41 kilograms per hectare versus 8. And this was largely because some of these sedges are they're very palatable, and both cattle and elk really zone in on them and love to graze them just right to the ground whenever they come across them. And then the other really strange, well, not really strange, the other interesting result from this was litter. So litter biomass was significantly different between the grazed and non-grazed treatments, but not in the way that we expected. So of course, with a grazing treatment, you're often going to assume that your litter will be reduced by the grazing treatment. But we actually found more litter in our grazed samples than our non-grazed samples. And we're potentially thinking that it's because of, maybe it's just the way that the animals are eating. Potentially it's a trampling effect that's leading to more downed litter in the areas that are grazed. But this has been consistent over the last 3 years of this study. We've consistently found higher levels of litter in the grazed versus the non-grazed treatments, which is really interesting. And it's healthy litter amounts, by the way. So stubble height again is one of those key indicators of use. It's representative of the leaf area, and it's where you measure up to the top height of the leaves of every forage plant, each of our grasses. And so we did an analysis on stubble height. We take stubble height in our grazed and non-grazed treatments to provide a comparison. And we saw a 37% height reduction of pine grass in our grazed samples relative to our non-grazed controls. And that's that highlighted, those highlighted numbers there. So we reduced it from almost 38 centimeters down to about 24 centimeters. which is a good reduction, and that has implications on things like flame length, because you have less height for flames to be high if a fire goes through there. And then another really key piece of this too, as part of our monitoring, was that our average stubble heights were never lower than the recommended minimums across any of our plots. So we have that stubble height guideline is our that third column over there, and it indicates, you know, like we had an average stubble height of about 24 centimeters for our graze treatments, and that's far above our 18 centimeter minimum guideline. So it's indicating that we're likely not having negative effects. And then this is just a really nice illustration. Well, it's not illustrations, it's a picture I took, but I think it really illustrates the fuel reduction quite well. So one of our important things that we really wanted to take a look at was the ecosystem health. So we monitored range health over the 3 years of the study, and this is just again for Cranbrook East from 2022 or from 2020 to 2022. And we found that there was no change in scores between years sampled. So it had the highest levels of scores at each of our range health scores across our macro plots for every single year. And this did not decrease or become reduced over time with the grazing treatment, because that's one potential problem, is that, you know, maybe a targeted grazing treatment, the system can handle it for 1 year, but then if you continue to have that pressure, it'll degrade over time. We did not find any degradation over time, and this also includes monitoring in the 2021 year, which I'm sure everyone remembers vividly, was pretty dry, pretty hot. So if we were going to see degradation, I think it would have been that year. And this is also a testament to how excellent the manager is on that piece of on that project. Another key indicator of ecological health is exposed mineral soil and litter cover. And those have also actually remained unchanged from 2020 to 2022. No statistically significant differences in cover over those years, which indicates that the community is stable. And again, the grazing treatment has not resulted in any increased bare soil or any reductions in litter cover. So those are all really positive. So what we saw is, you know, we have about a third of our fine fuels reduced, and yet we're not seeing any degradation in our key ecological indicators. So what does that mean? Well, in summary, grazing in our 400-meter intensive area of interest was considered moderate at about a third. Biomass and stubble height on grazed versus ungrazed areas showed a total live biomass reduction by 27%. And our key grass, pine grass height, was reduced by 37%. So it's likely that grazing would have a moderate effect on fire behavior in that critical zone, although through reductions in overall fine fuel biomass and height. So, and also ecosystem health has remained stable, which indicates that targeted grazing within these types of ecosystems is compatible with maintaining other important values. So that's all good news. I would like to acknowledge our funding support, which was provided through the Canadian Agricultural Partnership. The Ministry of Forests, oops, forgot to change that because it's a different ministry name now. Sorry, Ministry of Forests, forget the rest of it. The Wildfire Service, and special thanks to Reg Newman, our lead researcher, Shauna Larad, the range officer for the Rocky Mountain District, and our excellent tenure holder, Jordy Thibault, for volunteering to participate in this project. So really, I just want to cap this off by just providing this visual. So what we want to find for targeted grazing to reduce fine fuels and to reduce wildfire risk is we want to find a happy medium between this overloading of fine fuels that you can see in this area, or on that you can see to the right where it indicates fire hazard. So we don't want to have something like that, but we also don't necessarily want to have something which is indicated on the other side of the fence where you have this potentially unhealthy overuse situation. So we're really trying to find that balance in there, that's where we can provide safeguarding our infrastructure and our communities through reducing fine fuels without having any negative implications to other important values and the overall integrity of the ecosystem. So that's what 3 years of targeted grazing has shown us at our Cranbrook East site.
Okay, thanks very much. We'll open it up to questions. First, I just wanted to clarify the litter increase. Was that just like grass and vegetation litter? It doesn't count like pine needles and twigs and things like that?
Yeah, it's just the grass and vegetation litter. It didn't include like things like pine cones or twigs or anything like that. Just the vegetation.
Yeah, so, oh, we've got a hand up. Claudia, you can unmute yourself if you like.
Hopefully my Zoom system is working. It was problematic earlier. I'm curious about your category called other grasses. It contains one grass and the two sedges.
Mm-hmm.
The Northwest sedge, and your species are different than what I'm accustomed to. And then that high level of litter, I'm wondering if the animals are nipping the plants and then spitting them out. You said they're highly palatable, but with that high level of litter remaining in the grazed plots, and considering the texture of sedges that they're often sampled by our herbivores and then spit out, which is a consequence, you mentioned, inefficient eating, or you called it, but it could be, so they are reducing and in fact altering the vegetation, but they're not really consuming it. And if it's short term, we're probably not worried about the health of the animal. If it's targeted grazing, they're going to get their nutrients elsewhere. But is that a possibility? Am I understanding the result that litter was this year's plant growth and it remained behind after eating? So maybe, like sometimes we have 25% not swallow, 50% nipped, we're wanting 50% utilization, but really only 25% enters the gut. And, a quarter is left behind. We talk about that in range plants. Is that possible in this situation, this plant community, and this grazing treatment?
I think it definitely could be, yeah. So the way that we sampled biomass was we had our primary species. So, the community was largely dominated by pine grass, which is why we sampled it separately. And I do think it's difficult to find in the literature. Like there is some information, such as you noted, like there's some inefficiency around eating, especially when species are not necessarily palatable. The Ross's sedge is one, Carex rossii, that has a high level of palatability. So I think that one was definitely for, they definitely wanted to eat it because it was good for them. But with pine grass, which was our main species across the target or the area, our project, I do think that there could have been some of that, what you just mentioned, they're just not ingesting all of it. Yeah. And I do think partially too that it was likely from trampling, because they were at higher densities. Those animals were confined to that area for a period of time. So I think it's a combination of those two things.
I missed your statement of time. I'm sorry, I was technical issues entering at the beginning. Did you state your head per acre in your defining your treatment?
No, I did not. I probably should have.
Yeah, and it'll be very informative for others who want to replicate and to know, because that's a measure of how many bites per plant per time, of course, grazing intensity. So that would be good to know.
Yes, it was 100 and some odd animals over 2 weeks. So it wasn't a very long grazing period, but it was at a bit of higher density. I do have the specific numbers that are coming out in our annual report, though. Just don't have them in front of me.
Thanks. We've got another question. Jeff, go ahead.
Hi, thanks. I like the talk. I think this is important work because I know that in my part of the world, land managers are getting a lot of different kinds of messages about this. And my feeling is that context matters a lot. And usually those messages are not conveying very much context in terms of what kind of ecosystem and what kind of grazing. But it seems like there's this inherent question in a lot of these messages, which has to do with how much difference can you make in terms of fire behavior and likelihood of fire and fire severity and all that kind of stuff versus the effects of grazing for 1 year or 2 years or 3 years. And then what if that keeps happening over 10 years or 20 years or 40 years? And I think there could be maybe a lot wrapped up in what you called ecosystem degradation. And I'm wondering if you can go into a little bit more detail about that metric and what that entails.
Yeah, yes, for sure. So I think one of our key indicators is the exposed soil, which did not change over the 3 years. And then further to your point of, impacts over time, I think that that's really important. What we've found within this specific type of ecosystem, this pine grass dominated, recently thinned area, it seems that is resilient to a targeted grazing treatment. And one thing that I've found going through this project is that it's very difficult to accurately model fire in grassland systems. And so we have another project on the side that's looking at that, especially when you're looking at reductions that are relatively small, compared to how some of the other fire modeling has. Some of the other fire modeling is dealing with very large scale amounts of above ground biomass and different dynamics. But further to your point of degradation, we used the Ministry of Forests has a range health assessment protocol, and it looks at 9 key indicators that include everything from biological soil crusts, impact through trampling, things like exposed soil, recruitment of vigorous decreaser species, and several other different metrics. And so that's publicly available on the ministry's website, and it's standardized and used across the province. So that's what we relied on to assess the ecological integrity of the site, as well as those other indicators that come out of our plant community transects, such as bare soil and litter, which are pretty key indicators.
Awesome, that's helpful. Thank you. And I appreciate that getting posted in the chat that I'm seeing.
Perfect.
In the chat, Amanda, if you can see the question from Jen, was the biomass data you presented an average of all the years? How many years of data did you collect?
So the biomass data that I presented was from year 3. And we collected 3 years of data. So I'm showing the most recent year's results. All the results over the years will be provided in a final report at the end of this project, which will be upcoming in spring 2023. But this year, I just provided this year's because it's the most pertinent, and it also has there's been 3 years of treatment on that site. So it should provide the most relevant information.
Thanks.
And no, I can't see the chat. I don't.
Okay. All good. I was just thinking that for this kind of project, a question would come up about scale and trying to maintain that sort of sweet spot of intensity that you seem to found. So is there, and maybe this is just too complicated, but is there a way for you to know what that maximum scale would be? Or do you think that, is that contained in any of your other similar projects?
Well, we're exploring as part of this, we're exploring the ability to scale it up in a provincial level. I know that Claudia is on the line, and she can attest to how difficult it can be to scale up targeted grazing treatments across large areas of land. Although in the United States, they have had a lot of work that's been ongoing across the annual grasslands of California, where they utilize targeted grazing across large areas of land. But it's something that can be that there could be some difficulty implementing it across the province, especially with some of our terrain considerations. And 2, I think it's really important to note that this is providing a service. It's reducing wildfire risk as a complementary tool to other wildfire risk reduction techniques. But it's something that is where if a tenure holder on public land is doing this adjacent to a community, safeguard it, it's going far above and beyond their legislative requirements for holding that grazing agreement. And so it's something that probably should be considered for compensation, just because it is, providing a service. And I think that if we had some sort of ability to do that and to provide the infrastructure in place to really allow them to easily do some targeted grazing, it could probably be scaled up in some of our more fire-prone ecosystems and areas in British Columbia in a way that could be successful.
Thanks. Question from Bob, is the tenant likely to continue the grazing approach in future years?
I think that there is the potential that they could continue doing this grazing treatment in future years, but there would have to, I think, be some sort of recognition for the work and effort that they put into it through some form of compensation.
In these areas, obviously fencing must have had to be put in, but what about water developments and other pieces of the puzzle to make this a bit easier?
Absolutely. So for this site specifically, we had an electric fencing that was put in, temporary electric fencing, but of course that has to be put in. The animals need to be trained to electric fencing, and then it needs to be taken down as well. And then there was significant engagement by the tenure holder with the community to let them know that this targeted grazing treatment was going on, that there was going to be cattle, and there was going to be, you know, electric fencing across some of these trails because it's a highly used recreational area as well. And then there was also, as part of that engagement, a request for additional water sources to help support the treatment. And let me just go back to a map. So there was actually some folks in the community to the left, you know, that's within the that's right adjacent to the targeted grazing treatment. They put out you know, they put out hoses and were refilling stock tanks. One lady actually put out her own big Rubbermaid bin, and they loved having the cattle come in the morning and come drink, and they were like naming the animals and they liked seeing them. So it's pretty cute. And I think that that's one important thing is, you know, people do like seeing animals and livestock, especially if they're not necessary, if they don't necessarily come from that background. It's kind of a neat, novel, fun thing for them. So yes, those are considerations. There can be really positive outcomes from it, or alternatively, it can be a logistical hurdle that people need to overcome and need to have support for.
Yes. Oh, another question. Do you know if there are other grazers present, such as wildlife?
Yes, so across this site, there's a lot of elk in this area, in the Cranbrook area. So that's why we can't attribute all of the grazing, all the outcomes of the grazing treatment to cattle, but we can ascertain that a significant component of it is coming from the cattle because they're sort of targeted on that area. And we moved the cages just prior to the cattle going in. So we were trying to capture just the cattle grazing effect versus, you know, if we move them early in the spring, then we would be capturing both effects. So we tried our best to just make sure that we were capturing the effect of the cattle.
Great. Just more questions coming up here. Oh, from Claudia, heads per hectare and time needed. So we know that you said it was 2 weeks, right?
Mm-hmm.
And what's the size of this on your map?
I have it in a final report, but I don't really know if we want to go into doing calculations on this.
Maybe when this is posted, that could be part of the so this is being recorded and will be posted on YouTube, and we can have some other details put in.
Perfect.
Yeah. Any other questions? Good discussion so far. Just a question about economics. You know, we've got that big picture of hundreds of millions of dollars put into fire suppression costs, and there is a cost to all this fencing and the thinning that's needed. So do you think that this initial infrastructure and work that needs to be done outweighs other potential costs? Like, how does that look on that scale?
I think it's always good to be proactive around fire risk reduction. I mean, part of this, it would be good eventually to look at an economic analysis to see what the impact is. All I know is it would be good if we had a way to proactively manage to reduce some of those really high levels of fire suppressions funding that our province has had to undertake for the last, you know, 5-10 years or so.
Yeah. Oh, sorry, Claudia, I misunderstood her question. It was about the plot per area,
Pardon?
plots per area. Yeah, go ahead and unmute. If you like.
And I was just saying it's fine to answer that in future, but that will be something people want to know, because that influences intensity, how many head
Yes.
and how much consumption was happened. I'll pause and you tell me when there's time for another curiosity on my part.
Nope, go ahead. That's good.
Looking at your urban or your suburban wild land, if you will, interface in terms of costs, when insurance companies look at this, and they're not my favorite, but we're reducing risk, right? And surely the persons who live here on the west side of this image wish to reduce their risk, and hopefully there's financial benefit for that. Of course, they hope to not lose their home, but insurance rates can be phenomenal in these highly risky flood, fire, other hazard prone landscapes. Some people can no longer afford their insurance. And there are situations where municipalities have negotiated, so it takes lots of cohesive thinking to work with a commercial entity, such as a residential homeowners insuring, but cities have reduced their insurance cost when they've had a targeted grazing risk reduction treatment. So it might be, clearing a brush, and whether you did that with a masticating piece of equipment, livestock, mechanical clearing, whatever you're doing, there's potential. And that when you get the ag economist involved, just to prompt our thinking to think about, we're reducing potential future cost. It's very analytical, but it's a good thing to keep in mind. And who else might join the team to investigate?
Oh, yeah, absolutely. We are looking at insurance as a potential funder for this as a provincial program, because, and especially if a city has a cohesive fire management plan, wildfire risk reduction plan, and targeted grazing can be a component of that, that could be a good way to potentially fund these types of treatments across the province.
Any other questions while we're all together?
Oh, and I was able to just pull up the density. So our stocking rate was 0.43 AUMs per hectare, or 1 animal unit per hectare. It was 120 cows over 183 hectares for 13 days. I knew I had it somewhere handy, but I wasn't quite sure.
Was there any issues from the public in terms of, I don't know, people walking their dogs and the dogs chasing the cows and that sort of thing? Or?
There were signs put up at the trailheads that cross into the targeted grazing treatment area that animals like a dog should be on a leash. So there weren't any large scale issues, let's say.
Right. All right, well, if there aren't any other questions, maybe we'll wrap that up for now, let you have the hot seat. And just a reminder to everyone, next week, November 1st, Rangeland and Resilience for Rangelands, same time, same place.
Thank you so much.
Thanks very much. Round of applause.